Those shall not divide by 0. I love math! Trapezoid, how you gonna find the area? Gotta get the median, then find the height.
Question number 1, what does not pass the vertical line test? Remember the vertical line test, you actually just draw a bunch of vertical lines like I'm going to do on each graph. You can just put them at random places. And to review, when you have just one dot on the vertical line test, it passes. But if you're ever in a situation where there's more than one, then it fails. Okay, so those are the two options for the vertical line test, okay? All right, for example, on this one passes here because there's only 1 point. But here, it would fail because it's going through 2 points on that vertical line. So which one is not? This one looks like a good choice. Let's look at the other ones. I'm showing kind of green for passing or go. This works. Do you see how my vertical line is intersecting or passing through the graph? That one passes. So if this is a function, because it passes the vertical line test, we're again looking for ones that are not. So it's not going to be this one. Same thing here, passes, 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 then this one is a function. So this one is not what we're looking for. Same thing on this graph. I'll try to zoom in as much as possible. This one's the easy one. Okay, so a lot of students are probably going to think like, oh, it looks like a straight line down, but it's not. It's actually slightly curving, ever so slightly. So it's not a straight line down here. It's like just curving. So this one will also pass and pass. Come to me. There you go. You got to speak it. So that one is a function, so we're not looking for that one either. So our correct answer for number 1 is A. All right, number 2. Given this function, given the functions f of x equals x squared minus 8 and g of x equals negative x, negative 5 minus x, determine an equation for the combined functions h of x equals f of g of x. So we talked about going from right to left. And we're going to put the g function, put this in red here. The g function is going to go into the f function. Okay? So let's just see if we can color code this. I'm going to put f. Here's my f function. So let's write out the f function. X squared minus 8. And whatever g is, here's g, put it in red, I'm going to put that into that one right there. Do you see why I left a blank right here? So I'm going to now write negative 5 minus x right here. Right there. Okay, then I just need to simplify. Now, common mistake here probably is going to be a student trying to distribute the exponent to what's inside the parentheses. And that's incorrect because that only applies to the law of exponents. Like if you had something like this, then that would be x squared, y squared. But the only way you can do that is because you have factors, multiplication. You have subtraction there. So this part right there, you're going to have to do, I like to do the box method, because remember there's 2 of them. And you would not be so wise to multiply just the first and the last ones. You have to use FOIL or the box. You use a box. If you use FOIL, it's the same thing. You multiply first, and then you combine like terms or add. So negative 5x, negative x, negative 5, negative x. And then I'm just going to go ahead and multiply. So positive 25, 5x, positive 5x, and positive x squared. You can write any order you want, so now I'm going to write them in descending order. 5x plus 5x, because we just multiplied, now we're combining like terms, so now we're going to add, so that gives us 10x plus 25. And then here's a common mistake, it's forgetting about that minus 8. So let's put a minus 8 right there. So that would give us x squared plus 10x plus 17. And then I'm looking for this one, and the only choice we have there is A. A is our correct answer there. Remember, if they ever ask you a function like domain, then I can just graph this and then get the domain, and then find which one is more strict, most restrictive domain. Let's see how I can get that on there. Let's try folding the paper. Given the function f of x equals x squared minus 5, determine the value of f of negative 1. F of f negative 1. What does this mean? So student friendly would be, we normally wrote like two different functions. And so what we're going to do is first we're going to put a negative 1 into the f function, and then whatever our output is become our input for putting into the function again. So let's put an f of negative 1 into our function. Negative 1 times negative 1 is positive 1. 1 minus 5 is negative 4. So when I put in negative 1, I get negative 4. So whatever our output is here in purple, you're going to put it back into the function. I don't think I have my purple marker. Maybe I do. Whatever we got here in purple, right, that's our output, we're going to put back into the function again. So I'm taking the negative 4 and putting it back into this function. Then I get negative 4 squared is 16, and then 16 minus 5 is 11. 11 is your answer. So a little tricky that you basically have to do it twice. I have two functions here, f and g. Given f and g, determine whether each point is an element of f of g or g of f. Select A or B for each. Okay, so the first thing it's saying is that my x value is 3. And then the first thing I'm going to do is this one is g of 3. G of 3 is 7. And then I'm going to put that into f. So f of 7 is 4. And this does not say 4, so I'm not going to choose A. Let's try B. F of 3 is 2. So f of 3 equals 2. Now I'm going to do G. I'm going to put that answer into G. So G of 2 is 5. And that's what I wanted, 5. So the answer would be B. Let's try the second one. X is 9. So I'm going to do G of 9. Try a different color. G of 9. There is no G of 9 on the X values. So it can't be this one. Let's try F of 3. Sorry, F of 9. It's right here, and my output is 3. So the 3 now is going to become the input for my G value, right? So F first, put it into G. So let's look at G of 3, and the answer is 7. And that's what we wanted. So again, the second one would also be B. For the following graphs that represents a function, so they're already telling you it's a function, determine whether its inverse will also be a function. Okay, so how do we do this graphically to test is you're going to do something called the HLT, which is the horizontal line test. And it's pretty much the same thing. If you have more than one dot, then it fails. And if you have just one dot, then it passes, and then you can take basically the inverse. That's what it does, okay? So let's take a look at these graphs. Again, you just do the same thing. You can just draw a horizontal line, a couple of places. Try to zoom in this one. All right, so those were super faint, but I think you get the idea. Let's go ahead and go through these. So then if I go through here, this is 1 point, 1 point. It's probably going to intersect up here only at 1 point. So this one is, yes, you can take, too light, huh? You can take the, yes, you could take the horizontal line test. It's invertible, so you can take the inverse of that function. Let's take a look at this one right here. And if I just chose this one, that's 2 dots, so that would be a fail. So the answer for that one would be no.
All right, number 6, let's sketch a graph of the function and its inverse. You're given f of x equals negatives, parentheses x plus 3 squared. And you can get a table of values. Let's get a table of values. So I'm going to take blue. Maybe put in something like -3. -3 plus 3 is 0. 0 squared is 0. Opposite of 0 is 0. Maybe you pick something like -2. -2 plus 3 is 1. 1 squared is 1. Opposite of 1 is -1. Let's do things -1. -1 plus 3 is 2. 2 squared is 4. Opposite of 4 is -4. Let's go ahead and try 0. 0 plus 3 is 3. 3 squared is 9. Opposite of 9 is -9. So if I graph that, left 3, stay. Left 2, down 1. Left 1, down 4. And then 0, -9. Okay, so it appears that this graph is being symmetrical about this line. And we actually learned about this last semester, where this is the vertex form. And so this would be 0. So the opposite of that would be -3, 0 is the center. Well, now that we have these other points, you can just make them symmetrical going across. So this would be right 1, down 1. This would be left 1, down 1. This would be right 2, down 4. So this would be left 2, down 4. And you could just basically follow the dots. Okay, so this is what my graph looks like for the blue. And then what you could do is you could just take the points and make them symmetrical by just switching them. So 0, -3, -2, -1, -1, -4, -9, 0. Now, what you may want to have done is restrict it. And we should have restricted it maybe on this side. Doesn't matter which side you pick. Okay, so let's now graph this and see what happens. 0, -3. Left 2, -1. Left 2, -1. Left 1, down -0, -3. Duh, I didn't switch any of these. -1, 2. I just copied these. Bonehead mistake there. Okay, so that'd be left 1. Let's see, left 1. Left 1 down 2. Left 4 down 1. And then -9, 0. Okay, so this is what my graph looks like. And that does make sense. You've actually learned something like this back in Integrated 2 that, if you graph the line, it looks like a angle bisector. And then if you wanted to, you can also have just found the inverse. Divided by -1. Take the square root. Remember, you have plus or minus. All right, let's go ahead and switch our x's and y's. Divided by -1. So I have -x equals, this cancels, you're left with y plus 3 squared. Take the square root, again, plus or minus. And you have not graphed this one before. So this is your inverse. But probably would have been better using the order pairs. Hey guys, let's go over question number 9. F of t, g of t, okay. So I realize that people are getting lost on this symbol right here. If it's a dot, that's multiplication. If it's an open circle, this is your function notation, where you're gonna put, like, if that was the case, it would have been something like this, fog of t, and then you would do g of t goes into f. Well, this problem is just a dot, so it is just multiplication. This problem is simple as taking f, which is up here, and putting that, I noticed I did capital T's here, and then g, which is right here in yellow, 3t minus 5. And then you can just use your box and then simplify. So we're going to multiply, and then we're going to combine like terms. 3t to the third, -9t squared, minus 5t, plus 15t. These two are like terms, so my answer is going to be 3t cubed minus 14t squared plus 15t. All right, for number 8, determine if they are inverses. If they are inverses, then f of g of x will equal x. And then over here on the right side, g of f of x will also equal x to show that they are equal to one another, that they are inverses. Okay, so let's do this side first. I'm going to put g into f, which means every x value is going to go there. So we're going to put into f x plus 3 over 7, which is 7 over x plus 3 over 7 minus 3. So again, I'm taking all of this, I'm putting it for every x value, and this is my x value. Let's go ahead and simplify. Put that over 1, we have multiplication. Going to cancel those out, so we're left with x plus 3 minus 3. And then you're left with just x. Okay, so that's a good thing. Let's try it on this side now. This one is saying you're putting f into g. Put f into every x value. The notation we would write is g, and then the f is 7x minus 3. So every x value right there, we're going to put in 7x minus 3. So that would be 7x minus 3 plus 3 over 7. So basically it looks like the yellow box above. The only difference is now instead of in x, we have 7x minus 3. Let's go ahead and simplify this. We don't need the parentheses anymore, and then these will equal 0. So 7x over 7, and then that cancels, and then you're left with x. So they're both equal to x, so yes, they're inverses. If this was something like 2x, then it wouldn't be a inverse.
Have you always wanted to learn how to show your work? Well, follow my 10 math commandments, which is thou shalt show all thy work. And if you want to learn more, go to my math website, mrmathseng.net. Thank you.